adding and subtracting scientific notation. Now, this one is by far more complicated to think about, but once you practice the process and understand it, it gets a little easier. So, my first thing, and remember, we're going to write our answers in scientific notation. Got to remember that. So, the question I have for you to think about is how do you add 300 plus 20? How would you do that normally? Now, most students that I talk to, or most people that I talk to, they say stack them. Okay, line them up. And so over here, I will line those problems up. So 300 plus 20 is 500. And then you're saying to yourself, wait, no, that's not right. Of course it's not right. What do you mean? And this is like gets to this like adding and subtracting scientific notation is what do you mean by line them up? It means, and I think you're thinking to yourself, well, the 2 doesn't go there. The 2 goes to the right one place. So that should be 300. And then the 2 goes in the tens place. And so what you're saying by lining up is you're lining up the place value. So line up the place value. And that is what we have learned in adding. So the correct answer is 320. So we're going to use that as a basis to see how do we add our numbers. So let's take a look at how do we, if we change these two into scientific notation. Well, my first number, 300, would be 3, well, I don't have to put the point, 3 points. I'll move it over 2 places. So that would be times 2. Because it's a bigger number, I'm going to be positive 2 place values. And 20 would be 2 times 10. Now let's see. So the decimal would be over 1. So that would be 1. And now, if we add the first time looking at this, a lot of people make the error. Well, they take 3 plus 2, which is 5, and then they take 10 to the second times 10 to the first, and they multiply it together and go 10 to the third power. And do you see how the 5 matches with this and the sort of that place value matches that? So what we're doing here, if we add them the way that they are given to us, we are lining up the 3 and the 2 in the wrong place values. So remember, in scientific notation, the place value is the 10 times 10 part. So that's the place value. So if we look at that place value and this place value, we need to get those two lined up. So how do we get the line up? Let me write that down. Line up the place value. That is value. That is, and I'm going to circle it. I'm going to star it because that is the first step in adding or subtracting scientific notation. So how do we line up? Well, we need to, if these are the place values, they're not lined up because this has a place value of 2. This one has a place value of 1. It's the exponents. So I think I'm going to take this one. It would be nice to get it lined up to be a power of 2. Now, I just can't make this part 10 to the power of 2 by adding times 10 to the positive 1. I need to change this one to be 10 to the negative 1. So I can multiply by 1, or 10 to the 0 power, and change the form of my number. And what that does is that if I'm going to multiply this 2 by negative 1, that means I'm going to move that decimal 1 place value over, And see how that 0.2 is getting that 2 to line up in the next place value? So let's rewrite it. We have 3 times 10 to the second power. And I really like to keep the parentheses here because it keeps my numbers organized. Times 0.2 times 10 to the, now 10 to the first times 10 to the first is 10 to the second. And how I can think about this is 3 hundredths plus 0.2 hundredths would be 3.2 hundredths. So I'm going to write the words for that because that's sometimes 3 hundredths plus 0.2 hundredths. That sometimes helps me with the easier ones. It means that they are, well, they're in the same hundredths, right? So when I add them together, that means I can add the digits here and the digits here can add together to be 3.2 times, now the temptation is to take and add the exponents, but that only works with this is multiply. But because we're adding, see how it's hundredths plus hundredths equals hundredths. So hundredths is 10 to the second power. So what we need to do is think about that place value and what it means, that exponent means in the words to help us out. So you combine the same. They don't combine, but they are you just copy that place value down. And that's the answer right there. And it is in scientific notation. Now, another way to do this is instead of doing it horizontally, sometimes when I get to this point, I like to go vertically because it's a little easier to kind of line them up. So I'm going to start with that. So in this situation right here, I would go 3 times 10 to the second. So from here to here, I would kind of go here to this place. And then this was 0.2 times 10 to the second power. And we're going to add those. So it kind of gives us that like vertical part that we did at the top at the beginning in our thinking. So our decimals here, the reason why I moved it over is because it's the decimals line up. So when we say line up the decimals, we're really saying line up the place values. So 3.2 times now 10 to the second power because it's hundredths plus hundredths. Remember, it's plus. Hundredths plus hundredths is hundredths. So that sometimes is easier. When we're adding and subtracting, the place value stays the same. Well, we have to change it to make them the same first, and then it stays the same. So let's do another example. Let's do 7.2 times 10 to the fourth power. Minus 4 times 10 to the third power. And this is when I like to stack, because I like to do my subtraction in a stacked way rather than a horizontal way. So let's think. We need place values. So we're adding and subtracting. So it's a subtracting. So we need to make the place values the same. Now, can I make a suggestion? Always go up. It actually makes it a lot easier. Typically, you don't have to change it to pseudo. It doesn't land into pseudo scientific notation if you go down. So you want to kind of go to the bigger exponents. So 4 and 3, the 4 is bigger. So I'm going to multiply this right number times 10 to the positive 1 to make it a power of 10. And so over here, I'm going to multiply by 10 to the negative 1, which moves it into a 0.4. Okay, so here's where I like to stack them. So 7.2 times 10 to the 4th. Now notice what I did is I kind of gave myself some more space. I don't know if you realize, but back up above, I didn't give myself too much space, so now I'm going to give myself more space. I'm going to subtract 0.4 times 10 to the 3 plus 1 is the 4th power. So I've made the place values the same. So I'm going to kind of bring, as I'm kind of thinking about that, I'm going to bring it down here. Place values stay the same. And then the digits I just have to subtract. Oh, I have to regroup because I can't take 4 away from 2. So go to the 7, regroup 110. So that would be 12 minus 4 is 8 in that 10th place. And then bring down my 6. Oh, and there it is in scientific notation. So let's do another subtraction one because I know those are a little bit more complicated. 3. So 4.6 times 10 to the 3rd power minus 2.72 times 10 to the 3rd power. Oh, and what I was looking at the place value because I know I need to make the place values the same. And hey, they're already the same. So now I just need to subtract 2.76 away. Bring down that time. Don't forget the times 10 to the 3rd power. So the place values are the same. So that means my place value is the same for adding and subtracting. And now I need to regroup. So I need to put a 0 here. And I need to regroup from the 6 to make this a 10. 10 minus 2 is 8. 7. Oh, I need to do another regrouping. So 4 goes to 3, and I can regroup 10 with the 5 is 15. Minus 7 is another 8. Bring down that decimal, and 3 minus 2 is 1. So I get a final answer of 1.88 times 10 to the 2 power. That is in scientific notation. Now, if it said standard form, so write your answer in standard form, then I would, times 10 would be 2 places. 1, 2, so it would be, 108 is our answer in standard form. In scientific notation form, it is 1.88 times 10 to the 2nd power. 2nd power. Oh, 3rd power. Good thing I kind of looked up there. So that is a 3rd power, not 2nd power. Ooh, let me get my eraser. That is... So 10 to the 3rd power, which means I have to add one more place value. So that would be one more 0 to fill that place value. So it's 1,880. So that's what this scientific notation means, is that 1,880. All right, so another example. Now this one is, because it's the last one, it's more complicated. And I think you might know where it's going. Negative exponents. Oh. But it worked the same way. We just have to think a little bit more. Which one's the bigger exponent. So we'll write this problem. We're going to add this time 8.6 times 10 to the negative 6th power. So I notice that my place values are not the same. So my numbers are not lined up. Remember the 300 and the 20? That would be like putting the 3 and the 2 together. So we want to line that place value up. Now, which one's the bigger one? On negative numbers, is negative 8 bigger or is negative 6 bigger? Oh, so it's negative 6 that's bigger. So I want to get a negative 8 to be negative 6. So I'm going to multiply by 10 to the positive 2. So this time I'm going to have to do 2 place values. So over here I'm going to multiply by 10 to the negative 2 because I want that 10 to the 0 power or times 1. So I don't change the number, I just change the form of it. So what that will do is move that decimal 2 places over, fill it in with the 0, and we have 0.035 times 10 to the negative 6th power plus that 8.6 times 10 to the negative 6th power. So same place values. Now I'm going to add them together. So I think I'll stack them. 0.035 times 10 to the negative 6th plus 8.6, so line up your decimal places, times 10 to the negative 6th. Now remember, the place values stay the same for adding and subtracting. And now I just have to add those together, so I get 8.635. And I double check to make sure that that is scientific notation, and it is. I have a ones place between 1 and 10 and place values. Now again, if that's in scientific notation, which is what the directions at the beginning. If it was standard form for a number or a standard number, then we would take and move that decimal, negative 6. So that would be negative is a smaller number, which means I need to move it over this way 6 times. So 1, 2, 3, 4, 5, 6 is where my decimal will go. I'll fill in, how many zeros? 1, 2, 3, 4, 5 zeros. So 0.123 4, 5, 8, 6, 3, 5. And I'll just put a 0 in the front to say, hey, it's a decimal. And that would be in standard form. And that's a lot of place values. So what's kind of nice about this is it does clean it, in scientific notation, it cleans it up a little bit better. And that is how you add and subtract scientific notation, is making the place values the same, or you can think of it as making the exponents the same.